Hello everyone, this is another video where I'll be discussing questions, sample questions, sample MCQ questions for your CBSE board exam. Okay, so uh, let's start. Two charges plus Q each are kept at 2a distance apart. The third charge minus 2Q is placed midway between them. So the potential energy of the system is how much? Two charges are there. One is plus Q, another is here plus Q. Each are kept at a distance 2a apart. So the distance between them is 2a. Okay. Third charge minus 2q is placed in between them. So minus 2q is here. Okay. The potential energy of the system. So simple, very simple potential energy of the system will be it's like summation. Like let's not complicate it. Simply the potential energy of the system will be potential energy of this plus this. Okay. So first of all, we know potential energy formula is K Q1 Q2 by R. Okay. Minus K Q1 Q2 by R. Sorry. So here it will be mm, sorry K Q1 Q2 by R. Sorry. K Q1 Q2 by R. So K first this 2 suppose Q square by 2A plus minus K into 2Q square by this is A minus K into 2Q square by A. Okay. So we just have to add it. So K Q square by A 2A minus 2kq square by a minus 2kq square by k. Okay, so this is 2a. So this is kq square minus 4kq square minus 4kq square. So mm, this is what minus 3 minus minus 7 q square by 2. Okay, 7kq square by 2. K is 1 by 4 pi, so 7q square by 8 by epsilon naught. Okay, so this is your potential energy U, right? Minus 7q square by 8 by epsilon naught. Yeah. Alright. Yeah. Okay. Next is two identical small conducting balls. B1 and B2 are given minus 7 Pc and plus 4 Pc. Pc means picocoulomb. The picocoulomb is what? 10 to the power minus 12 coulomb. Okay. So two identical small conducting balls B1 B2 are given this much. They are brought in contact with the third identical ball B3 and then separate. Yeah. Okay. Final charge on the ball is each ball is minus 2 picocoulomb. Okay. So see, first is B1, then this is B2, this is minus 7 picocoulomb, this is plus 4 picocoulomb. Okay. They are brought in contact with a third identical ball B3 and then separated. Okay. So B3 is neutral, like identical ball. B3 is neutral and charge is not given. Okay, initial charge is there. Okay. Suppose it is cell charge is Q. Okay, so when in contact with B1, the final charge will be minus 7 plus Q by 2 on each B1 and B3. Okay, after that B3 now has minus 7 plus Q by 2. Now it is made in contact with B2. Okay, yeah, yeah. Um, so this now will be minus 7 plus 4, that is minus 3 plus Q by 2. Okay. because this will be added and yeah divided by 2, so by 4 minus 3 plus q by 4. Okay, so now b1's charge is minus 7 plus q by 2, b2's charge is minus 3 plus q by 4. Okay, so the final charge on each ball is minus 2. So let's see, minus 3 q by 4 is equal to minus 2. So minus 8 q is equal to minus 8 plus 3, the minus 5 picocoulomb. Okay, so see this one, or you can go, if you go this way, minus 5 picocoulomb, and which will be the answer. Okay, got it? Because final charge in each ball minus 2. So B2 is the last one that is being touched. So it's minus 2 here. Minus 3 plus q by 4 is equal to minus 2. Right? That's why minus 5 piece is the correct answer. Next question, the quantum nature of light explains the observations on photoelectric effect as. Okay. The quantum nature of light explains the observations on photoelectric effect as how the quantum nature expresses minimum frequency of incident radiation below which no electrons are emitted. Yeah, that's correct. Maximum kinetic depends only on the frequency which is yeah, it depends on the frequency of incident radiation. It also depends on stopping potential. Okay, also depends on work function because kinetic energy max is equal to h nu minus h nu naught, isn't it? Correct. Yeah. When the metal surface is illuminated, when the metal surface is illuminated, yeah, electrons are ejected from the surface after some time. When the metal surface is illuminated, electrons are ejected from the surface after some time. No, electrons are ejected instantaneously. Okay, the emission of electrons is an instantaneous process. So electrons are ejected instantaneously. So this is wrong. This is wrong. Photoelectric current is independent of no. Photoelectric current depends on the intensity of incident radiation because more the intensity, more will be the number of electrons. Okay, and more the number of electrons, more will be the charge. So that more will be the current. Okay, more will be the current q by 2. So this is wrong. So the first option is correct. Minimum frequency of incident below which no electron. This is called a threshold frequency. Okay, this is called your threshold frequency, the minimum frequency. All right. So this one is done. Next question. The radius of nth orbit in Bohr model of hydrogen varies with n as. Simple question. Rn is equal to 0.53 angstrom n square by z. Correct. So Rn is directly proportional to n square. Okay. Option C. A straight wire is kept horizontally along east-west direction. Okay, straight wire is kept horizontally along east and west direction. This is west. This is west. Okay. If a steady current flows in the wire from east to west, the magnetic field at a point above the wire will point towards. A straight wire is kept horizontally along east-west direction. If a steady current flows in a wire from east to west, the magnetic field at a point above the wire will point towards. Okay. A straight wire is kept horizontally. If a steady current flows in a wire from east to west, the magnetic field at a point above the wire will point towards. Above the wire, the magnetic field. Right? Current is from east to west. So if you use your right hand thumb rule, if I put this in thumb in this direction, then my fingers will be curling in this direction, right? Like to inward towards the screen. So that will be cross. Okay, so the magnetic field will be cross. Cross means what? Cross means this is east. So this is north, this is south. Okay, answer will be south. Okay, it means Cross means going into the plane, going into the plane. So into the plane means suppose this is your north, so this is your south. Okay, like this is kind of 3D I'm doing. Okay, all right. Yeah. So answer is south. Magnetic susceptibility for a dielectric material is magnetic susceptibility for a diamagnetic material is diamagnetic material magnetic susceptibility is what? Small and negative. Okay, it's less than zero and it's very small, so small and negative. Option 6. Galvanometer resistance 100 ohm is converted into an ammeter of range this using a resistance of 0.1 ohm. Okay. The ammeter will show full scale deflection for a current of about. Alright. Galvanometer resistance 100 ohm. Okay. So the resistance of the galvanometer is 100 ohm. G is equal to 100 ohm. Okay. Ammeter of range. So current in the ammeter is 1 ampere. We're using a resistance of 0.1 ohm. So the resistance of the ammeter is 0.1. So ammeter will show full scale deflection for current of about. So that is the question. Converted into an ammeter. How to convert galvanometer into an ammeter? If we give a resistance in the parallel of a galvanometer, that will the system will be an ammeter, right? So this is your Ig. This is your I minus Ig. Yeah, this is your I. So I minus Ig whole into R is equal to Ig into G. Correct? We know the equation. I is 1. 1 minus Ig. R is how much? 0.1 is equal to Ig is Ig into G into 100. So 0.1 minus Ig into 0.1 is equal to Ig into 100. Correct? So it will be 0.1 is equal to 100.1 Ig. Okay, so Ig is equal to 0.1 by 100.1. Okay, so that will be the answer. You just check which one is the correct answer. Okay. Okay. Next question. Circular loop. Circular loop of radius r. Circular loop of radius r carries a current I. Another circular loop B of radius r is equal to r by 20. R is equal to r by 20 is placed concentrically in the plane of A. Okay, in the plane of A. Okay, so this is your this one. There is another one. So this is a r by 20. This is a r. Magnetic flux linked with B is proportional to. So this is a B. Magnetic flux linked with B. That means flux is equal to magnetic field into area. Okay, magnetic field will be of the bigger loop and area will be of the smaller loop. because flux is linked with that surface only, with that loop only. So that's why the area will be of the loop B. But the magnetic field is because of the circular, bigger circle. Okay. So the magnetic field is mu naught I by 2r, which is the magnetic field due to a circular loop of radius r, into area of the smaller circle is pi r square by 4, isn't it? R by 2. So this r are cancelled out, and the answer is mu naught I r divided by 8, isn't it? Mu naught I pi r divided by 8. So your magnetic flux is proportional to r. Okay, so this is the answer. Magnetic flux proportional to r. Okay. Next question. Figure shows the variation of inductive reactance XL of two ideal inductors of inductance L1 and L2 with angular frequency omega. The value of N1 and L2. Variation of inductive reactance XL of two ideal inductors L1 and L2 with angular frequency omega. Value of L1 and L1 by L2. Sorry. Okay. Inductive variation of value of L1 by L2. Inductive reactance XL. Okay. So XL omega graph is there in this one. Okay. So suppose this is your XL1, this is your XL2, correct? So XL1 is equal to how much? Omega L1. Yeah. Omega. Omega for L1 is how much? 60 degree. So sorry, 30 degree. Okay, okay. Oh, okay. See this 30 degree, this XL. Oh, all right. XL is equal to omega L, correct? So L is equal to what? XL by omega, correct? And if you see what is the slope of this, these are two lines, that means they must have slope. Slope, we know slope is equal to tan theta is equal to y by x, correct? So here y is what? XL, x is what? Omega, correct? So XL by omega is your L. So L is what? L is equal to tan theta, right? Got it? Yeah. So L1 is equal to tan theta 1. So for L1 theta is 30 degree. So tan 30 degree is how much? Tan 30 degree is root 3, right? Tan 30, 1 by root 3, sorry. 1 by root 3. L2 is tan 60 degree, which is your root 3, correct? So L1 by L2 becomes 1 by root 3 by root 3. So 1 by 3. Okay, our answer will be 1 by 3. Very good question again. Yeah, I hope you understood. It's based on slope. If there are two lines in a graph, there must be an angle is given. That means slope is what they want to know. Okay, so slope is this one x. Okay. All right. So here the phase difference between electric field and magnetic field B in electromagnetic field. Simple phase difference pi by 2. Okay. All right. Coil of N turns is placed in a magnetic field B such that B is perpendicular to the plane of the coil. B changes with time as B is equal to B naught cos 2 pi by T into T. The magnitude of EMF induced in the coil will be maximum. So is that B is perpendicular to the plane of the coil. Okay. EMF will be maximum. Very simple question. See, uh, in terms of, so flux is equal to what? NBA cos phi by cos theta. Magnetic field is perpendicular plane of the coil. Okay, that means suppose this is the plane of the coil. The area vector is in this direction. Magnetic field is also in the same direction, perpendicular. So theta is 0. So cos 0 is 1. NBA. So n into b is how much? B naught cos 2 pi by t into t. Area is how much? Area is not given. Area suppose A. Okay. So the magnitude of EMF will be maximum at, okay. So del phi by del t minus d E is equal to EMF divided by del t. So minus N A B naught minus sine, okay, 2 pi by t into t into 2 pi by t, correct? All these are constant. So sine 2 pi by t into t is what counts. When it will be maximum? When sine theta will be maximum? When sine theta will be maximum? When theta is equal to 90 degree. So 2 pi by t into t is pi by 2. Then only this thing is maximum. Pi cancelled out. So t is equal to t by 4. Okay, where n can be, where we can put a n here. N can be 1, 2, 3, 4. So n t by 4 now. Okay, again a very good question. Very good questions are there here. So please solve them. Okay, last question in this MCQ series, like in this MCQ, like this one. In Balmer series of hydrogen atom, as the wavelength of spectral lines decreases, they appear. In Balmer series of hydrogen atom, as the wavelength of spectral line decreases. Okay, wavelength decreases. So this C. So these lines are energy lines actually. So if wavelength is decreasing, that means energy is increasing. Okay. So equal space equal no. Further apart, stronger in intensity. Closer up. Yes, further apart and stronger in intensity. Why? Because the wavelength is equal to hc by lambda. So if wavelength is decreasing, energy is increasing. So energy is increasing, there will be further up like this. Okay. And then the option B will be answer. Right? Yeah. So yeah, these are the questions. Yeah. Right. So I'm doing one video every day. So I hope you are solving those questions. 12 questions every day we are solving. So if you solve 12 questions every day for 1 month, it's like 360 questions. Okay, so 360 questions a lot, and that will give you 12 out of 12 in your MCQ. Okay, okay, that's it. Thank you very much. Another thing is. Uh, I'm also starting individual I'm also giving individual classes for physics for 12th board for last 2 months. If anyone is interested, they can mail me. I have given a mail in the description, and they can mail me directly, and so that we can start immediately our individual classes. Okay, there will be classes will be in Google Meet, right? So that you can ask me your doubts and everything. All right? Yeah. Thank you.